little bit about end behavior really quick before we get into these stations. And then if you had any questions on that practice quiz, we can probably address them at the end of class today. If not, come in during IC and then we can address them, or lunch. Okay, so when we're talking about end behavior, I think this is the hardest one for everybody. When we're talking about end behavior, we're going to look at two things, okay? Or we're gonna have two options. Basically, remember, end behavior just tells us what's happening when X gets really, really big, okay? And one of two things is going to happen. Either it's going to have a horizontal asymptote, or it's not going to have a horizontal asymptote, and it's going to be going to positive and negative infinity, right? Either it's going to be approaching an asymptote, or it's going to be going to infinity. Those are your only two options, okay? And so then once you figure that out, so you look at your function and you decide, does it have a horizontal asymptote or does it not, okay? If you decide it does have a horizontal asymptote, remember there are two things that would give it a horizontal asymptote. If the top is equal to the bottom, or if the top degree, and you know what I mean when I say top, I hope, the top degree is less than the bottom, you're going to have a horizontal asymptote, right? You are not going to have a horizontal asymptote if the top degree is greater than the bottom. Okay? So once you've made your determination, does it have a horizontal asymptote or does it not? The easier one actually is the horizontal asymptote, because if it has a horizontal asymptote, your end behavior is the horizontal asymptote. That's it. It's just the horizontal asymptote. So once you find that horizontal asymptote, you can just write it as the end behavior. So remember, with this one, you're going to have a number, and this one, you're going to have 0 as your horizontal asymptote. But then literally all you do is write your end behavior by saying the limit as x approaches infinity and the limit as x approaches negative infinity. The only thing you have to write here is the horizontal asymptote, and you're done, okay? So you just put your horizontal asymptote there, and that's all. This one's a little bit more challenging because we have to figure out which way it's going and whether it's going to positive or negative infinity. But if you end up on this route, then you have to plug in infinity and see what happens. Remember, so say if you had something like x to the 4th over x cubed, this does not have a horizontal asymptote because the top is bigger than the bottom, right? So then we decide what happens when I plug in a really, really big negative number and when I plug in a really, really big positive number. So I should put plus or minus infinity because you plug them both in. So what you're going to do is you're going to write on your paper the limit as x approaches infinity and the limit as x approaches negative infinity. And all you're going to do is you're going to plug in infinity and see what happens. And then you're going to plug in negative infinity and you're going to see what happens. Okay, so when you plug in positive infinity to this, we know it's either going to positive or negative infinity. That's our only options, right? So we know the answer is either going to be positive infinity or negative infinity. So when I plug in a positive number, I get positive over positive. So the limit as this one approaches infinity is positive infinity. And then this one, negative infinity, if I plug in a negative, I get a positive over a negative. So this is going to negative infinity. That's it. Does that make a little more sense?